All right, so let's begin. Thanks everybody for coming to this talk. This is a deep dive on Amazon Managed Blockchain. My name's John. I run the Amazon Managed Blockchain team, so thanks again for coming out. Real quick, by show of hands, how many folks are in the Amazon Managed Blockchain preview or have played around with the service so far? Okay. How many folks here are familiar with blockchain technologies in general? Like how many people have played with Ethereum? Show of hands, Ethereum. Any of the Hyperledger projects? Show of hands, couple. Okay, cool. Well, so to begin, we're going to talk a little bit, this might be a refresher for some of the folks who raised their hand, but talk a little about when AWS talks about blockchain, what do we mean by blockchain? That if you're out kind of talking about blockchain with peers or colleagues, some people might think about it as cryptocurrency and Bitcoin, some might think of it as distributed ledger technology, and so we always start off by kind of taking how does AWS approach the space and how do we define the technology? Next, we'll introduce the new service we launched in preview at reInvent, Amazon Managed Blockchain, talk a little bit about some of the features, some of the things you can do with it. And then we'll take a deeper look at one of the open source frameworks we support in Hyperledger Fabric, in Amazon Managed Blockchain, Hyperledger Fabric, talk a little bit about how that works, show you a quick demo of the console, and then at the end I'll leave some time for any questions the folks in the room have or folks on Twitch have. All right, so starting out, what is blockchain? And it's convenient that I'm doing this presentation right after one on ledger databases. But for those of you who weren't in the room just before or weren't watching it on Twitch, to think about blockchain, first, we want to talk a little bit about what a ledger is to begin. And this is kind of thinking about how AWS introduces this technology. And I guess taking a step back at reInvent, for folks who were there or were watching Andy Jassy's live keynote, we announced two different services, a ledger database called Amazon QLDB and Amazon Managed Blockchain, which is a blockchain service. And kind of stepping back to think about the space, when we spent the last year thinking about, talking with customers about when they're thinking about blockchain solutions or talking about decentralization or ledgers, what are the use cases that they have? And what we really found when customers were talking about blockchain, they really had kind of two overarching use cases. And one of the use cases, which will kind of evolve into the ledger use case, is that customers really didn't need a decentralized solution. They were fine with centralized database, kind of like MySQL or something they would have before. But the problem was that there was no way to audit and kind of have a tamper-proof history of everything that has happened. That the way that they did it today was they'd have a centralized MySQL database or NoSQL database, and then have a bunch of audit logs. They need to figure out a way to secure those audit logs. They need to figure out a way to query the audit logs and go back in time to see what happened if, say, they needed to go verify the history of something. And then they have to make sure that no internal actor tampered with it. So a lot of work to maintain the kind of reliability of that database. So when we're talking to these customers, we found that, hey, blockchain has this tamper-proof ledger in it. And some customers were looking into that, but blockchain was meant more for decentralization, which we'll spend the rest of this talk talking about. And with that comes a lot of complexity, not as fast performance because you're dealing with a system designed for decentralization. And so customers were kind of left in a weird space. There wasn't really a great solution with their current technology, and blockchain was a little bit complicated. They really just wanted like the ledger part of the blockchain, not the decentralized part of it. And so that's where Amazon QLDB comes in for that first use case, which is a ledger database that makes it easy for a customer to have a centralized system to track in a tamper-proof way the history of all the state changes that happen to that system. So it makes it super easy. One database, basically you can query the journal in the global state, which in the last presentation a lot of that those details went into. And that solves that use case really well. Centralized ledger database. But for a second set of customers, we found some different themes that kind of implied that, hey, a centralized ledger wasn't going to meet that use case. And this is where kind of the evolution of Amazon Managed Blockchain to solve those use cases came. And so I'll go through a couple of these themes. I won't go through every single one, but you'll see kind of a common pattern. And the first one was when we were out talking to customers, there's a lot of existing business networks today that rely on a central authority. So I might want to transact, say, with company A, transact directly with company B, let's say in finance, some sort of asset transfer. But the way my financial system works today is there's a central authority that I trust and that company B trusts. And instead of transacting directly with company B, I work with the central authority that then works with company B. And that central authority takes time, so it's not very efficient. Usually they take a cut, so it's expensive. And usually I have to audit that central authority anyway to make sure they did what they were supposed to do, and audit company B to make sure that they ended up getting what I thought they should have had. So all sorts of inefficiencies and cost when all I really want to do is transact point to point with somebody else. Transaction could be an asset transfer or some other thing. A second theme that we saw when thinking about these use cases is that there might be an already existing consortium of customers, and they could achieve a better outcome by sharing information, but they can't really agree on the technology stack to do that. And one example could be I might say, all right, everybody, we're going to share data, and I'm going to have a database. I'll hold all the data and expose it to you. And somebody else in the consortium might say, well, why should you own the data and give me access? I want to have a copy of it too, so I'll own it. Or maybe nobody wants to own it for regulatory reasons or something like that. Oftentimes what happens is those groups of companies create a new legal entity like a joint venture, and that joint venture is the thing that owns all the IT. And it's just, the whole thing is just really complicated, and it takes a lot of time. It isn't very efficient, when in reality, all this group of customers want to do is share information and have an up-to-date view of everything that's going on that's independently verifiable. Kind of moving through, some groups of organizations just need an up-to-date view of everything. And if everybody has their own data silo and then has some sort of data transfer process, it's hard to have one point of view of everything, especially if, like in a supply chain, an asset is being tracked across a lot of different silos. How can you independently verify that nothing was missed and go back in time to see every state change that happened to that asset across different database systems? Oftentimes there's things around automation where you want to make sure if something happened and you don't want to spend a lot of time auditing it. Is there a way that you can kind of codify a contract in code? And so kind of when you think about all these different themes, there's kind of a theme of it's not just one customer. These are groups of entities trying to either transact or share data. They want to do it in a way that is independently verifiable, meaning I don't need to call you and audit you to kind of agree on what happened, that I've got my own view of the world that I know is real. And trust. And so all these themes in together in these use cases where centralized system can't do this. And so when AWS thinks about blockchain, it really comes down to eliminating the central authority in a business network and takes kind of what we have on the left side, where you've got a lot of entities interacting with some central authority, to a true point-to-point system where everybody has an independently verifiable view of what happens. When we think about blockchain technologies then that can enable it, we kind of think of it a little bit like a layer cake of technologies, that a blockchain isn't a ledger, it has a ledger, kind of like an ERP system isn't a database, it has a database. So blockchain technology at the base has a distributed ledger that everybody owns a copy of, a consensus mechanism so that every entity in the network can decide what the state of it is and what gets written to that ledger that everybody owns, and then a smart contract execution engine on top. When we think about blockchains, we think about it, the interface that developers are using is building smart contracts and working with smart contract engines. So I won't spend too much time here, but it might be a quick refresher. The bottom level of the kind of layer cake of blockchain technologies is the ledger database. And kind of in the last presentation, they went through kind of what is a ledger. The same sort of concepts apply, that the actual thing the blockchain technology gets its name from is this hash-chained set of blocks. And this is how it kind of becomes cryptographically immutable, is each block has a set of transactions and the hash of the previous set of blocks before it. So basically, you can go and make sure that if somebody tampers with a block of transactions and says, from like a financial point of view, like say, I owe somebody $100, I can go through and quickly see that something has been tampered with. A key difference between a ledger database and a blockchain network, though, is that every single organization in the blockchain network has their own copy of this data. And that is pretty important because it kind of enables everybody to be on the same playing field, versus if I had a database and say expose that data to you, if I say cut off your access or deleted the database, you would lose access to that. You wouldn't really be in control of your own destiny. So that's a key difference between when we're talking about centralized ledgers and blockchain, is that every entity in a blockchain network has a copy of that data. Same concept, though, applies as quantum. You've got the journal, which is the blockchain, the hash chain of blocks, and then the global state database, where if you're writing applications, odds are your applications are hitting that global state more often, because that's like your bank account balance. So you might not care to see every single transaction that led to you having $100 in your bank account. your application probably cares more about what's the state of it. But if you had to go back in time and trace all of the state changes that happen for a key, you can do that through the journal, and that's that immutable state change database that you can query. So once again, in the different open source blockchain frameworks, these are all implemented and built differently, but the same concepts apply. So on top of the ledger that then every organization or every entity in the blockchain owns, you've got a consensus mechanism. And this is how the network can decide on what blocks or what transactions those blocks to add to the network. And different technologies have different ways of doing this depending on the level of trust in the network. So in, say, a public network, you have to solve against a paradox, Byzantine fault tolerance, which has to do with not being able to necessarily trust information about the state of the network that's being given to you. This is something that, say, Ethereum and Bitcoin on the public networks need to do. Incredibly poor performance and takes a lot of energy, but you have to use these sorts of algorithms to guard against malicious actors on the network. For networks, though, that, say, you know everybody in, like, say, a consortium of banks, you're not really worried about a random node showing up and saying, hey, actually commit this block and having not the correct information in it. And in that case, you have a different algorithm that, say, doesn't need to guard against Byzantine fault tolerance, and you can have a higher TPS on your network. And so we'll talk a little bit more about that later. There's a variety of different ways. There's also a lot of interesting new research being done using new algorithms, but also hardware acceleration and other things to be able to boost the speed of which these algorithms can run. And then at the top level of kind of the layer cake is smart contracts. And different blockchain frameworks, smart contract is basically code that's executed in a verifiable way on the network. There's a variety of different, smart contract languages depending on the framework that you're using. Smart contract can write and read information from the ledger, but also smart contract can interact with things off of the ledger too. And there's a lot of interesting development here because storing large amounts of data on the blockchain isn't necessarily cost effective or efficient. So you could, say, store the hash of an object in some other system in the blockchain to verify that that object hasn't been tampered with when you retrieve it, or store, say, PII data that you can't store in an immutable format on a ledger somewhere else. And so there's a lot of interesting ideas on how to leverage off-chain, on-chain interactions, or linking other blockchain networks together using interactions through smart contracts as well. This might be a refresher for some. There's different types of blockchain frameworks. A lot of them boil down to if you're in a public network or a permission network. Public networks are a lot of the ones you hear about in the news, Bitcoin, Ethereum. Public network, anyone can join and take part of. And you can actually just create a node, join the network, and within the network, you have cryptocurrency to incentivize people to join the network and mine blocks and commit blocks to the network to add transactions. And so on these networks, it takes a lot of compute power to do this. And so people need to be incentivized using some native cryptocurrency to spend their energy bills and compute power to do that. But anyone can join. So that's why you need this financial incentive to run these expensive proof of work algorithms to make sure that no one's tampering with the network. On the right-hand side are permission networks, where once again, it could be a supply chain or a financial consortium or some group that knows each other and isn't allowing any random entity to join. For those, you don't necessarily need anybody mining because the algorithm isn't guarding against Byzantine fault tolerance. And there is not necessarily cryptocurrency involved because the externality of wanting to be in that network and spend time running the software is a business externality, like your supply chain is 10% faster, maybe you're able to unlock a new business use case, something along those lines. So different approaches, but still the underlying technology stack is the same components. So customers are experimenting in many different industries, and I really like this slide because it shows just really the breadth of areas where people are trying to use decentralization and blockchain technologies to make their businesses more efficient, increase transparency in their business processes, or even unlock just totally new ways of doing business and offering products to their customers. And you could spend an hour talking through all these different points, but I'll bring out a couple of interesting use cases. I mean, for real estate, right now, if you want to sell a home, there's an expensive escrow process that takes a cut and also questions and disputes on who owns what property or deeds getting lost in kind of government database systems. And so there are startups and some larger companies experimenting around saying, what if we can host this on a blockchain network, make transactions on changing deeds atomic and code it up in a smart contract, and kind of reduce the need for a middleman escrow in the process. And that's kind of one very simple way that people are leveraging blockchain to see if they can make the process cheaper and more efficient. For loans, there is a pilot that went, I think, in South Africa. I don't know if it went into production, but the process of getting loans approved took a while because there were a variety of different silos along the way to keep an identity and their creditworthiness and information about that person through the process of them applying to get a loan and that being issued. It took a long time. There was a lot of shuffling of data around, making it an inefficient process and also error-prone as well. And so the different stakeholders in this process got on one of these permission blockchain networks, were able to track the person and the attributes all the way through the process and made issuing loans less error-prone and more efficient. There's some ideas around patient records, and that comes into a question of, well, what data can you store in a blockchain and not? But there's a variety of large healthcare companies and insurance companies and small startups trying to figure out, is there a better way to integrate data across the payer-provider networks, making things, once again, more transparent, less error-prone, and more efficient. From power and utilities, the idea of prosumers putting power back into the grid and having a trackable smart contract to track how much energy in their payments for putting data back or power back into the grid. And then just even identity. How do you track identity of, say, a workforce over a variety of different silos, employers, and even credentialed programs as well for education? So lots of ideas, but once again, boils down to those main points that I talked about in the beginning. There are groups of customers trying to share data, transact, and do this more efficiently and more transparently than they could either with a middleman or with kind of a lot of auditing and not independently verifiable data. So I want to kind of double-click down into two specific use cases. These are the ones that, particular ones that we're excited about. One is using blockchain in supply chain, and this kind of shows up in several different use cases. But once again, kind of, if you think about decentralization, it lends itself well to these sorts of applications because in a supply chain, you've got a variety of different suppliers. And oftentimes, to make supply chain more efficient, you need to have a really good view across your entire supply chain network. Or if you want to do a recall, you might want to know this end product had components far upstream, and if I want to recall it, knowing what components are kind of bad, and so you can identify the products that you want to recall and where they are, and making sure that you've kind of got an end-to-end view of what's going on. Oftentimes today, each member in the supply chain has their own set of data that they're looking at. People are spending a lot of time transferring data back and forth to get an idea of what's going on. And when we're talking to customers, there isn't necessarily an easy, up-to-date view across these huge global supply chains. Also, from payments on all these parts moving around, it's kind of clunky on kind of building this global network and making sure the right suppliers are getting paid and things are the quality of goods being shipped are robust. So this kind of putting the supply chain 2.0 on a blockchain enables all these parties to be on the same network, have the same view, and everybody can independently verify what they're seeing is real versus spending a lot of time communicating and trying to verify if what they're seeing is correct. We've also seen a lot of interest, blockchain and financial services, and I'm not really referring to cryptocurrency here, more so on these enterprise use cases where once again, a consortium of banks wants to trade assets around or even build a new asset class. Can you do that using a blockchain network across all the parties who will be involved? Identity and creditworthiness, which I already talked about, a use case for that. The ability for banks to better work with other banks on shared data sets or customer rewards programs as well, and rolling that out across, once again, many people in the value chain for a customer rewards program to make them operate more efficiently. So we talked a little bit about some blockchain use cases, some of the high-level technologies, how customers are experimenting it. But one feedback that we got was, there's a lot of ways we can see this applying to our different businesses, but it's really hard to use this stuff. And for anyone who's set up a blockchain network, like using Hyperledger Fabric, I think you know what I'm talking about, that there's all sorts of hardware you need to provision, a lot of different complex distributed systems you need to configure, A lot of advanced networking, especially when you're going from a POC environment to one across multiple members. You've got to configure a lot of advanced networking. There's governance. For a private blockchain network, you've got to stand up key management like an HSM. You've got to govern the network. You have to scale it up for performance. Some of these components need to run things like Apache Kafka for high availability for certain components. So there's a lot of different complexity involved in setting this stuff up. And that's just setting it up maybe for a production or a test environment. Going to production, there's all sorts of other things as well. So the feedback we got was, hey, we really want to play with this more. We have some use cases we might want to scale from POC to production, but we need some help in doing this. So in April of last year, AWS released our blockchain templates as a quick way to help customers get up and running to kind of have these test environments on AWS with Hyperledger Fabric and Ethereum. But that was kind of a quick thing. We still got feedback of, hey, we want a more robust solution. And that's where Amazon Managed Blockchain came in. So we launched Amazon Managed Blockchain in preview at reInvent of last year. And the goal of the service is to make it easy to create and scale blockchain networks using popular open source frameworks, Hyperledger Fabric and Ethereum. And we really got feedback from customers that these two open source frameworks cover most of the permissioned and public blockchain use cases that you might have. And also, if you think about it, it makes sense to have an open protocol for blockchain, that these networks are going to be wide and open. And the goal is to make it easy for customers to join and have more momentum behind it. So we're super excited to work with these open source projects. A couple features I want to go over at a high level to describe the service. First is it is fully managed, that you can create, say, a Hyperledger Fabric permission network in 10 minutes. And I'll show you later in the presentation view of the console. But it really is easy in a couple of clicks to stand up the whole network and easily invite other AWS accounts to come and join. They create their peer nodes, and you've got a fully operational blockchain network amongst the sets of peers that you want to join. We support two different frameworks, as I mentioned, Hyperledger Fabric and Ethereum. We'll go into more details about Hyperledger Fabric later in this presentation, and that's currently available in the preview. Ethereum is coming soon. And the key is, open source variety is important, that you might have a use case that lends itself to one of these permission networks, and we believe that Hyperledger Fabric, for most use cases, is the right way to go. It's got advanced permissioning. It's got kind of a way to easily identify organizations in the network. It was kind of built from the ground up to do that. However, you might have a use case that, say, you want to interact with a public network, and you can use Ethereum to interact with Ethereum public network, or build a private Ethereum network for certain specific private use cases that lend itself better for Ethereum. Or you might have experience writing smart contracts in Solidity, which is Ethereum's smart contract language, and that's what you want to use. Or you might have experience with Fabric. And so, we want to give customers a choice to really use the right framework for the job they need and the one that they're most used to. So we're excited to offer both of these frameworks. Move on to the next point, decentralized. So, we built the service in a way to honor the way customers want to build these consortiums, which is not I create a blockchain network and I own it and I'm going to invite you to join, but when I leave, the blockchain network is destroyed. We really want to make it so these blockchain networks live as long as the network should exist and outlive the owner creating it. And one example is like if I created an S3 bucket and then shared it with all of you. You all have access to the data. Maybe you could write data to that bucket. But if I delete my AWS account, that bucket is gone. So you could argue that I've got more power in the situation because I can delete all that data. With Amazon Managed Blockchain, I could create a network, invite all of you, and then I could leave. Or there's actually in decentralization, the way we built it, there's a voting API where we can all vote on who to add and vote on who to remove based on a voting policy for the network, like unanimous or majority rules, or maybe I decide everything. But whatever that voting policy is, that's the rules engine that runs on how the network can make these decisions. And if I get, say, removed from the network, even though I created it, doesn't matter. That network is still fine. So it really embodies the idea of building these networks where everybody is in charge of their own destiny and has an equal seat at the table. And those features are coming in preview. They're not currently available today, but they'll be in the preview soon. Amazon Managed Blockchain is reliable and scalable, that for Hyperledger Fabric, there's actually a component called the ordering service that is the kind of component that's in charge of taking in transactions, putting them into blocks, and then sending the blocks back out to different peers on the network. In open source Fabric, Apache Kafka is used, and Kafka is a great open source project, but it's not quite built for how the ordering service in Hyperledger Fabric needs to use it. So instead, we actually use the same journal technology that underlies QLDB to back this, to make it more robust and more durable than using, say, something like Apache Kafka for the ordering service. Also, reliability standpoint, we integrate the Fabric CA, which is the root CA, which holds the certificate basically that identifies your organization on the network, and then is the chain of trust for all the users you create for your organization on the network. We use, instead of an open source, it's kind of just a file on disk, it's not very secure. We use AWS KMS technology, so HSM grade tech, to secure those root certificates. Managed blockchains, low cost. I'll talk a little bit about the pricing model later in the presentation, but you pay as you go. You only pay for the resources that you use. And finally, it's integrated. And this is coming soon. It's not available yet in preview, but it's integrated in the sense that you can take all the blockchain activity happening on the network and in near real time send it to QLDB, the ledger database, for off-chain secure storage to, say, do off-chain analytics and other things with that data without, say, putting a lot of load on your blockchain infrastructure. So we talked a little bit about Hyperledger Fabric. This is one of the frameworks we support. It's currently available in preview, and it only creates permission networks. So if you have a use case where you have a known set of participants, Fabric is quite possibly the way to go, but it doesn't support any of the kind of public network functionality. Chain code is the name of the smart contracts that you write for Fabric. You can write them in Go, and I believe there's a Java SDK as well. And they're executed in Docker containers on the network, and that's how this kind of secure execution works. There's a lot of different configurations you can change, like the validation policy or the number of endorsements you need, and we'll talk a little bit about that when we take a deeper dive into Fabric later. And there's no inherent cryptocurrency, so that's an important concept. If you're thinking about blockchain from a public network standpoint, there's a bunch of organizations, you can do transactions, you can write kind of a cryptocurrency into a smart contract, but there's no native cryptocurrency like there is for Ethereum. And so leading into Ethereum, the other framework we support, many of you might know it because there's a large public network with associated cryptocurrency. With Ethereum, you create smart contracts using Solidity, and then you use the cryptocurrency Ether to basically buy gas in a public network to run these on a public network, because you kind of need to pay for the kind of public network to spend compute cycles running your smart contract. In a private context, there's other different algorithms you can use. You might hear proof of authority, proof of stake, which I think proof of stake, the public network is going to switch to, but proof of authority is a much higher throughput algorithm to use. But depending on your use case, if it's private, you can switch it up and increase the throughput. Very scalable. So the public network is thousands of nodes all working together to maintain the state of the network. So proven to be very scalable. You can create some permission networks, although the access control features of Ethereum native are not nearly as robust as Fabric. There are some other forks of Ethereum. You might have heard of a project called Quorum, which was open sourced by JP Chase, that kind of puts in some access control ideas in, but it's still not as robust as something like Fabric for many of these use cases. And that's kind of the use cases we see for private networks for Ethereum is where anybody can see all of the data on the ledger. Like if you go to the public Ethereum network today, you can see all the data written to the blockchain. You don't really know who represents the different accounts that are transacting, but you can see what all the transactions are. In some cases, I guess you can encrypt some of the data before sending it on, but then you've got kind of another layer of management for the things that are going on that public blockchain. So in Amazon Managed Blockchain, it really is straightforward to create a network. And I said I'll show you in the console a little bit later in the presentation. You just choose the framework you want, invite the members that you'd like to join, create your peer nodes, and then start deploying applications to the endpoints the peer nodes expose. This is kind of I took this from our documentation, a more architecture view of what's going on when Amazon Managed Blockchain creates one of these Fabric networks. As you can see here, and once again, to hammer the point home, this is a network across different AWS accounts. So we might all have a different AWS account. I create a VPC that's in my account. I create, say, a client node with the Hyperledger Fabric client. And when creating that client node, you actually download the open source SDK. We didn't make like an Amazon fork of Hyperledger Fabric. We're staying true to the open source, and it uses the open source SDK. We didn't change the API, and you have to use a special Amazon client. And so in my VPC, I create a client node, And then in Fabric, or sorry, in Managed Blockchain, when you create a network, in kind of our VPC, we launch all these components. We create, when a network is created, a Hyperledger Fabric ordering service, and then each member creates their membership. That includes a Fabric CA, which is kind of defines your member using a root certificate. So like any user that, say, organization A creates is defined by a root certificate in the Fabric CA for that organization. In this example, there's 3 different members. That could be 3 different AWS accounts. Or say you wanted to create a simulating test network in one AWS account, you can create 3 members in one account. So it depends on kind of the network that you're trying to build, the right way to go about doing that. But for each member, once again, you have the Fabric CA, which defines it, and then you create 1 or more peer nodes. There's a variety of different instance types you'll be able to use. And then your kind of member and peer nodes are stood up. We'll talk a little bit about peer nodes in the Fabric CA in more detail when we talk about Hyperledger Fabric components. For each network that's created, a VPC endpoint service is created. And each member in the network, so each AWS account, can create a VPC endpoint against that VPC endpoint service to make it so that your communication with your blockchain components doesn't need to go through the internet. So we actually don't expose any of this to the internet. The networking has it so that I can create a client machine in my VPC, create a VPC endpoint, and that client machine can talk to all of the different peers in the network, which is important for endorsements, because the way Hyperledger Fabric works, your client machine needs to talk directly to each peer in the network, whether you own it or not, to get that endorsement before submitting it to the ordering service to be added to a block. So that all happens through these VPC endpoints. You don't need to expose these components to the internet, which is a good thing. So who owns the network? The answer is really, you could say nobody owns the network, or everybody owns the network. That these networks are designed to outlive the person who created them, assuming that that's the policy that you put when creating the network. When you invite members to join, in the preview right now, actually just decide which accounts and they're automatically added. But during the preview, we'll add in that voting feature I talked about, where the network votes on whether to add a certain account ID or not. And you'll be able to track the different votes, who voted on what, to really democratically govern the network. And once again, the settings on the voting rules are also, you vote on those, and they're set at a network level. Each member pays for their own resources. And Managed Blockchain manages some of the shared components like the networking and the order as well. And so, once again, it's kind of allows each member of the network to really own their own destiny. From a pricing dimensions point of view, it really is pay as you go. There's no upfront costs. Certain components are billed per second, and our pricing is on our network. In the preview, everything right now is free, but the pricing for when the service is generally available is on our website. But you pay basically per second for your member, or if you have multiple members, say on a test network, you pay per second for each. You pay per second for the node and the instance type and the local peer storage, and that's what stores your copy of the Ledger database. And then you pay per gigabyte of transactions that you write to the network. The VPC endpoint you need to create is billed separately, and there's also standard data transfer rates that are kind of usual for all of our database and other services. So it truly is pay as you go. You want to spin up a test network, you have it up in 10 minutes. You can run whatever tests that you want to do, run a POC, but if you decide to, say, scale it to production or shut it down, you can easily do that. So the goal is to make it really cost-effective to experiment with these technologies and then scale it out to a full production size network. And to hammer that idea home, we've got actually 2 different editions. We've got our Starter Edition and Standard Edition for Hyperledger Fabric. Both of these are actually, don't let Starter fool you. These are both production-grade systems. It's not like the Starter Edition doesn't have HSM grade technology backing the Fabric CA. The real difference is just the scale that you want to run. For Starter Edition, it's a little less expensive for a member, but you don't have as many members maximum in a network, as many peer nodes, and some other limitations on more of the scale and availability. Although for many use cases that, say, don't have a huge network or aren't running tons of transactions per second, like a lot of provenance applications, sure, this could be fine. This could be a total fine way to run your production network. Standard Edition allows you to scale a little bit larger, has more different instance types that are available to run kind of more throughput on the network, higher availability, and is kind of more beefier package. So depends on really your use case and what you're trying to do. But both of these are great solutions to experiment with and then scale to production. But once again, the preview right now, we're not charging for that at this time, and there isn't this choice yet. These are kind of looking a little bit forward to the general available service. All right, so let's take a deeper look at Hyperledger Fabric. I think kind of this is one when thinking about the different transaction flows, when you're thinking about how these networks are set up and how they process transactions, it's a useful kind of diagram to go through. And you can kind of think about how this works in relationship to the different components that I showed you on the architecture slide and thinking about how the networks are set up. And so the first thing is when I propose a transaction, remember I'm running that client machine, the Hyperledger Fabric client, on an EC2 instance in my VPC or somewhere else, but wherever that is, it needs to have access, like say a direct connect, into your VPC to access that VPC endpoint. Because remember, the CA, which has basically all your identities, and all of the peers, their endpoints are exposed to you through that VPC endpoint into that VPC. So I create a transaction. What Hyperledger Fabric actually does is, depending on the endorsement policy, my client will go contact peer nodes in 1 to n organizations on the network. And that's where that networking component is important, because that client needs to access securely not only the peers that I create and pay for, but all of your peers as well. So when it sends a transaction there, each peer simulates the transaction to decide whether to validate it or not. And assuming it's validated, it sends the read-write set back with kind of an endorsement saying, this transaction's endorsed. And the client then goes around and collects endorsements from, once again, whatever the policy says on the number of endorsements from discrete organizations that you need. So once the client has enough endorsements, it'll send the transaction with all the endorsements to the ordering service. And that's that shared ordering service for all of the components in the network. And what that ordering service does is it'll take the transaction, verify that it meets the policy, order a certain set of transactions based on the settings into a block, and then send that block back out to all of the peers. And remember, each member in the organization should be running one or more peers, and the goal of the peer is to validate the transaction, which already happened earlier in the process, and then store a local copy of the ledger, which is the source of truth. Remember, the ledger database is the journal and the global state. So when it retrieves the new block, it adds that block to each peer adds the block to their journal, does another validation check to make sure that in that kind of quick cycle time, nothing has changed to make that invalid, and then commits it to the ledger, updates the global state, and that transaction has now been added to the network. And so that's happening basically for every transaction that's going on. That process happens. So when you think about scaling out, it's important to think about how complex is this to simulate on each peer. So that's thinking about compute power. How beefy does each peer need to be? And then also just the throughput of, from an endorsement policy perspective, how many peers are going to be doing this at once? And so that's one question comes up from customers is how many peers do I need in my, or what instance type should I be using? That's one way to think about it. As I mentioned before, we've augmented Hyperledger Fabric in a couple different ways. One is instead of using Apache Kafka in the ordering service, we use the same journal technology that backs Amazon QLDB. We believe that it's a more durable solution because Kafka is not quite meant for the way that the orderer is using it. So we think this is a better fit. For the Fabric CA, which once again is that thing that defines an organization in the network, we're not using the soft HSM, which is what's used by default. We're using AWS KMS, HSM-backed technology to secure each of those CAs. Hyperledger Fabric runs chain code. It's executed on the network. Also, chain code can do system operations like run ledger queries, query the journal as well. Fabric supports 3 languages, Go, Node.js, and Java. That's once again the kind of where we see a lot of interesting innovation happening on how do you codify, say, supply chain logic into a smart contract. And oftentimes, smart contracts are interacting with other parts of the system, or it kind of just serves as one component of a much larger architecture as well. And actually, we released an interesting workshop on our AWS database blog showing an example on how to build a secure, transparent donation system for NGOs, complete with a front end that kind of shows you end-to-end what a full stack blockchain application might look like. Each member in the network has a CA that defines the membership, and then one or more peer nodes. We talked a little bit about this already, that a peer node stores a local copy of the ledger, and that's owned by you. And that kind of has some interesting ideas because, everybody owns a copy of that data, and if I get removed from the network, I still have the data, the state of that network up to the point where I've been removed. So it's different way to, we ask customers to think about it a little bit differently instead of, previously where I might have a data set and expose it to you, but you can't actually copy it. You can only access it for the period of time I let you, and then I shut off your access. In blockchain, kind of everybody owns the data that's exposed to them. Peer nodes executes chain code, endorses transactions from clients, and validates the transactions again before they're finally committed to the ledger. So one question is, do these frameworks have any access control? And the answer is some of them do, some of them don't. Fabric does, and actually has two ways that you can limit who can see what transaction. So the kind of more brute force way is Fabric utilizes what's called a channel. And a channel is a kind of shared subledger among a set of people that are on the network. Now, it could be one-to-one. It could be that everybody in the network is on the same channel, and that means that everyone has access to all the chain code and ledger data on that channel. But it might be that out of the 10 people on the network, 5 of them are on channel A, 5 of them are channel B, and some set are on channel C. And you can create these subledgers to limit which folks in the network can see or access that specific channel. And there's a variety of commands to create these channels, invite people to them. People in the channel can vote on certain things. And that's one way to limit who can see what in a Fabric network. There's also another feature called private data in a Fabric network, which is kind of scopes it down to even sub-channel level. And how that works is basically, if I do a transaction with another party, I can make it so that only those two people can see the contents of really what that transaction was. And on the actual ledger to everybody else in that channel, you see some evidence that something happened, but you don't really know what it was and who was between. Now, for some use cases, you don't even want that. And Fabric today doesn't support that to my knowledge. But in many cases, it's fine to just obscure what's going on. And actually even more useful because both of those parties can go back to a ledger that's maintained by a set of people that's more than just those two people to maintain that this thing happened. So that kind of allows you to use the channel as more of a notary versus just having something between two people and then having to rely on those people agreeing on what happened, kind of the idea that why you want a decentralized solution in the first place. To close, Fabric has endorsement policies as well. And this is what I was talking about in that earlier slide where the client will go and interact with peer nodes from different organizations to endorse that this transaction should happen. And that, once again, that's totally configurable. In some use cases with incredibly high throughput, you might want very few endorsements, and based on your use case, that might be okay. In some, you might want endorsements from every single person in the network. It might slow down the rate of what's going on, but it might be important for your use case. So real quick, let's switch over. I'll show you the console of the preview, and I'll have a link later in the presentation about where to sign up, but we're adding new accounts each week. And so we'd love to work with you on your use cases. So here's a view of the managed blockchain console. All these are kind of exposed via API as well, and so we have a command line and SDK client as well to interact with and create these networks. So if you want to create a network, it really is quite simple, like I showed in that earlier slide. You select the framework that you want. Right now, Ethereum's coming soon, Fabric 1.2. Put in the network name, a description, hit next. And then when you're creating a network, you also have to create your initial membership, that you can't really have a network with no members in it. Actually, the way to delete a network is just everybody leaves, that there is no, at this time, terminate network API. It's just the network exists until the last person leaves and the network is terminated. But when creating it, you need to have that like initial bootstrap member. And so I put in my name, description, and then also, when I create a membership, remember, the Hyperledger Fabric CA is kind of the Fabric component that defines what a membership is with that root certificate. I need to kind of create my admin username and password, that initial identity for my organization on the network. So I can do that again. and then hit next. This is basically all the inputs that I needed to create the network, and then I'd hit create network and member, and it would create. I've actually already created one here, so I can show you what that looks like when it's created. You've got a network ID, and then here's some of these endpoints that I was talking about. So for that ordering service, I create a VPC endpoint, and then this is how I would access that endpoint for the ordering service that's exposed through the VPC endpoint. This is the VPC endpoint service name to create the VPC endpoint. And as you can see here, right now there's only one member, it's me, in my member ID. Click that, and I can get a better view of the membership. This is how I interact with my Fabric CA, which is how I create new members. I get the certificates from there to then interact with the data plane components and identify them as myself. And this is the endpoint for that. And then here's a peer node that I created, and here's the peer node endpoint as well. And so when I want to say interact and query the ledger, install and invoke chain code, all sorts of things, this is the endpoint that's exposed there. Once again, this is all totally managed, and in a couple clicks, if I want to say create another peer node, I can do it in a couple clicks, and then that info will get spun up, added to the network, and configured correctly to interact with all of the other components in my membership, but also the whole decentralized network that's created as a whole. And real quick, I deleted this network, but here's a view of multiple members in one network. So all of these different ones, these two are in different accounts, as you can see here, and then I created another one for fun in my account as well. And for all of these, they create their own peer nodes. I get a view of what's going on, but obviously I can't create a peer node in this member. I can only control my own. But I need to know who else is in the network so I can interact with them, and this is that view that you get. And finally here, if I say it was an invitation that I want to accept, I see an invite, and then I can join this network by creating a member because I've been invited to join and create a member there. So that's a quick overview, and then you create your client, your VPC, you install the open source Fabric SDK, configure it with these endpoints, and then start writing whatever smart contract code and interacting with your network for your use case. And we're actually going to release a blog post soon that automates some of the creation and configuration of this client. So in our documentation and in the workshop that's on our database blog, we go through the methods on how to do that, but we'll keep coming out with easier ways to get started and start experimenting with Fabric. All right, let's go back to the presentation. Okay, so information on the preview. So once again, it's available now. You can sign up. We're adding new accounts each week. There is a resource limitation, though. In the preview, you only get one network, up to 5 members in that network, whether you're inviting other accounts who are on the preview or just creating networks yourself. You're limited to 1 peer per member and a smaller amount of storage per peer. And then some of those voting features aren't available yet, although we are rolling out new features every week, and so stay tuned for some of that, and also stay tuned for Ethereum support. Also, we're not billing during the preview as well. This deck will be available online, but here's some links that'll be included. One is the preview sign-up, our webpage, getting started guide, documentation, also information on just open source Fabric itself. That at the core of the service are these open source frameworks. So for understanding the types of things you can do and how you can interact with these blockchain frameworks, the open source docs are also a great place to start. What's not here is the database blog example, but if you search kind of managed blockchain AWS database blog, you'll find that information. So once again, we'd love for you to join our preview. We've got a lot of great, interesting use cases so far, and we've got customers like Workday, Liberty Mutual, Philips, Verizon, GE, all experimenting with blockchain technologies for use cases across manufacturing, supply chain, financial services, healthcare. And so we'd love to work with you on your use cases as well, and to help enable interesting use cases for decentralization. So that's all I got. Thanks a ton for coming to this presentation. We've got around 10 minutes left, so I'll take some questions, if anybody has any. Yes?
Is there any plan to support building dynamic endorsement policies? Let's say use case you have financial transactions, and you need to dynamically change the endorsement policy depending on the size of the money that's being saved in a debt note or
Yeah.
policy, whatever it is. now are now available to kind of be built if you want in a 1.2 Hyperledger Fabric.
Yeah, so for the rest of the room, the question was, are we enabling dynamic endorsement policies for, say, a Hyperledger Fabric network? So we haven't tested that yet. That's kind of on our list to test. But if it's available in Fabric 1.2, I don't think we've done anything to stop users from doing that. And so we can go back and verify it. As I said, we're still in preview and kind of working through some of the verification on that. But if it's available in Fabric, I think it should be active in our preview right now.
It's not available directly, but through the chain code interface, you can.
Yeah, you can write a sample to do it. So I think you can, but it's not. You'd have to do some custom logic to do it. Now I think based on kind of customer feedback, this would be a great sample code, and we'll over time add things where if there was a code snippet that you could insert into your smart contracts to enable things like that, that might be something we could put on the database blog or our AWS Labs GitHub. But
Like a policy, a document like you can attach to S3s, and then you would just attach it to your network, and that would kind of easily change the endorsement rules itself.
yeah.
Nice, thank you.
Yes.
Will there be a pricing mechanism to balance the big players versus small players belonging to the blockchain, or do you see everybody having to bear the same costs?
Good question. So the question was, do we see big players and small players paying the same amount to be part of a blockchain network, or kind of who bears the cost? That sort of question. And so our pricing is actually just pay as you go, depending on the amount of resources that you spin up. And so it might be that a smaller person in the network doesn't say need as many nodes, and so they're paying less. But a large player who needs to endorse a lot of transactions or is doing a high throughput of activities might have larger instance types or more nodes. But all the pricing is pay as you go, and there's a rate per second depending on the infrastructure you deploy. I think another interesting point is, though, who's writing the most? And that data written pricing dimension that you pay per gigabyte of transactions that you create and kind of propose to the network, that also kind of says that somebody who's larger on the network, one way to measure large could be the number of transactions and the size of those transactions you're putting. That person will be paying for the cost for those transactions. And so we did try and make it so that even though everyone's sharing some responsibility in the network, if you're doing more things, you'll be running more hardware or writing more data. But more information on the pricing is available on the website, so you can dive in and just see what the rates are there as well. Any questions on Twitch? No? All right. Well, that's all I got. Thanks a ton. I'll stick around also if anybody has any questions afterwards. But please sign up for the preview, and thanks again for your time. Oh.
There was one.
Okay.
People are asking if are there any tutorials available for
The question is, are there any tutorials available? And for managed blockchain, there are. There's one in our documentation, which is a getting started guide. I think there's a link on that last slide. And there's another workflow or workshop that we added on our AWS database blog. I think that the title might be Writing a Smart Contract for Hyperledger Fabric, or something along those lines. It was published in the last 2 weeks. And that example is part one of it's going to be a larger series that kind of builds on each thing that we've created. But the first part that we published creates kind of a sample one-member network to just show you some of the operations of creating your kind of basic infra with managed blockchain, adding your first smart contract, and has a cool web app that you also deploy that's the front end to kind of give you an idea of what a full stack application might look like. Because your end users probably aren't going to be interacting directly with Hyperledger Fabric. They're going to have some web interface that will then fire off things and transactions into the blockchain. Future posts in that line are going to be on how to then create multi-member channels and things like that really nail home some of the ideas around decentralization. But to start with, it's kind of just the basic 101, how to stand up your first bit of stuff in managed blockchain. So there'll be a lot more tutorials coming, but we've got 2 right now that are out there. Yes?
Sorry, another question. Will the ordering service always be kind of paid by AWS itself and run by the AWS itself, or is there any cost that you see in the future? Do you maybe share it between all the nodes? Or?
Got it. So the question was, for folks who didn't hear it, With the ordering service, it's provisioned for a network. AWS is kind of running it now. Who's paying for it? Will people need to pay for it differently in the future, and how does that work? So, right now, when you create a network, an ordering service is created. There's no explicit charge for that. That's kind of a shared cost for the network. And if you can think about it, that's almost covered in your network fee. And so we're not exposing that as a separate thing you pay for, because really it's owned by everybody. And so there isn't an explicit call out for that. That's how it works today. Okay, well, thanks a lot. I'll stick around if anybody has any questions that come to mind later, but thanks again for your time.